try to capture all these points in a single test, but possibly more likely we'll have 2 or 3 competing tests, or that's what I'm hoping for, to see how we might capture different ideas and which one will be more suitable for testing intelligence. And I think that the whole discussion finished on the note that embodiment is important, and there was a suggestion that if you have a virtual, so the Turing test but is done in a virtual reality where you don't have a blind judge, but you have avatars and you don't know which avatar is the machine and which avatar is the human. And then by observing that interaction, we can tell, or we can try to tell which avatar. So you have the embodiment of intelligence, so we can represent things like gestures and voice tone if we decide to have voice. I think we didn't decide to have any verbal interaction, but you can get the idea is you have the embodiment of intelligence as well as the background models. And I think we stopped at that note with, is it safe to say majority agreement? That might be a good idea?
Well, I think we went a little bit, that we then added to that, we looked at the bot prize, so this idea of using a games engine to do that, basically. So you have the 2 actors within a virtual environment, but a constrained one, obviously, where you're actually fighting aliens or whatever it might be. So we talked about that quite a bit and found that it's actually, it's being done at the moment. It started last year. It's called the Bot Prize, and they run it in the IEEE conference.
Okay.
So a variation of that might yield some fruit, perhaps.
Well, I eardropped in your discussion. You were talking about Unreal Engine and
or some of these other engines for World of Warcraft. I think Darren mentioned too.
Okay.
So that might be a much more complex interaction.
When we get to
I think that where we'll stop.
Sure.
Actually, we are recording today.
Point of information, is that bot prize, is it intended to be something like the Turing Test, or is it more just...
No, it's intended to be like the Turing Test. They call it the Turing Test in a gaming environment or something like that. So they mentioned Turing Test in there.
Well, I would just say, from my point of view, any test that has a paired comparison between a human and the entity is the Turing Test.
Yeah.
I mean, that's it. I mean, it's if one thing is equal to the other thing. I do not believe in limiting the scope of the content. And if you have the computer avatar and the human avatar interacting in sim space, I mean,
there is one difference, and that is that in Turing's test, the most you could hope for is to be indistinguishable from a person. But in the bot prize test, you could actually be smarter than a person.
Okay. But I'm not talking about prize. We're talking about, say, in SimCity, where if you have 2 people interacting. Well, fine, that's interesting. You can't be smarter. Fine. Then you can't tell, though. You choose the smarter one. In other words, there are 2 entities there. One wins. Well, so obviously that's the better one. That's the smarter one. Sure. And the judges, I don't think the judges would be, or if the judges chose the dumber one, or the loser. That tells you something right there, I think.
I don't think there are even any judges. It's just a score-keeping mechanism. Is that correct?
No,
what would that tell you?
There are human judges.
Would it tell you that you need smarter judges?
Smarter participants.
Actually, on the point of judges, if I may point, in several studies of the Turing test, I didn't see anybody highlighting calibration. How do you know that the judgment of the judge is correct, is acceptable in judging who's a human and who's machine if you don't have a calibration? I mean by calibration is to have that judge having 2 human, and he can say they are human, and then 2 machines, and he can say 2 machines.
With respect to it, specifically specified in quotes the average person. I mean, if you just take a random sample of people and your sample's big enough, then surely that's good enough.
The idea is that the machine is indistinguishable for the person. I choose 3 professors, psychologist, a computer scientist, and a philosopher, and then a journalist. And that's, I mean, but the point is, can they, whoever you choose...
Well, are these the average person?
No, well, they are the average person, but they make it a more interesting test, I think, and give it a greater validity.
Yeah, I think that's what we're looking for, is the validity. If this is going to be a test of intelligence, then how we can ensure validity.
Yeah, but the Loebner Prize has been held by other people using off-the-street people.
Did they get the same results on the same systems?
Well, that's confounded by the rules of the contest being held that particular year. So you can't compare one year with another, except pretty much when I'm running it. And even last year, for example, in order to test the 5-minute rule, I had just 5 minutes to interact. So, but as long as in every year that there has been a paired comparison, which is for the last 5 years or so, since 2004, so 5, 6, 7, 8, 9, 10, whatever, there's never been a case in which a computer has, except when the contest was 2.5 minutes, which is not very much time, has judged mistaken the human. In 2008, they had 2.5 minutes and there were mistakes. That was so fast you only get 2 or 3 interactions.
Yeah, I've got a couple of notes. I wasn't able to attend the workshop yesterday, so please forgive me for those who were here yesterday if I'm repeating material that was laboured over yesterday. I'd be particularly interested to see any putative new test be kind of general, be kind of thrown into the hurly-burly of the world, rather than be some narrow domain-specific test. And the reason for my rationale for thinking this goes back to Descartes, who famously gave a suggestion for why he thought you couldn't have an intelligent machine, because at the time Descartes could only conceive of machines that were designed for a particular purpose. So he imagined a robot-like creature that had lots of effectively hardwired systems. Well, obviously that couldn't be really intelligent, because in the real world we have to react to situations that are unique. And I think Descartes was onto something there. I think my own intuition, for the little it's worth, is that interacting with the real world, the general unconstrained real world, in some way involves such a lot of general skills. It's a very difficult problem, and things like the DARPA prize, where you're driving over unconstrained real territory or driving along a townscape, rather than some AI lab where we can control the environment much more. These seem to be much more interesting tests of intelligence. So my 2 penn'orth worth would be to move towards something that's unconstrained, even more so than the virtual world, because there are only a limited number of actions, I believe, in virtual worlds relative to the total freedom that we have in the real world. So although it's a very interesting test, and if that was the only one on board, then it sounds a good way to go, but I'd be very keen to have something that was real world based. So.
To add on to that, with some of the more general tests for different AI agents, I think it's important not to just have the human as the baseline comparison, that due to different environments, due to different taskings, there will be the need to compare different intelligent agents. And if you can make this test general enough that it could be tested as the human as a baseline, or test different artificial intelligence agents even against themselves in the context of some environment for testing, I think that would be useful. So for humans to humans, you have the IQ test, aspects of that. There's some metrics associated with that, whereas most of the discussion here right now seems to be about more subjective judgment of different individuals. But I'd say the question is, can you make it a little more objective? Are we there yet or not?
So in your opinion, you would prefer to see a metric-based test very similar to the IQ test for humans?
Well, something to explore, if that's possible. It may not be possible, but the question is, can you get there? And it's at least something to explore beyond just the subjectivity, I think.
Yeah, and this was something we came round to repeatedly yesterday, was the idea that the binary nature of the Turing test is to a certain extent what makes it very difficult and is perhaps not necessarily that helpful to the development of intelligent machines. The sort of idea of pass failing, and the idea that we might, is there another way that we might have a test that does have some degree of some degree of passing, if you like, or some level of intelligence.
More multiple metrics kind of tests.
Yeah, we discussed lots of options.
I mean, you could have a Turing test where how long does it take the human to decide, the judge to decide which is the human, and that would sort of do it. But another thing would just be to provide, IQ tests that have
But Minsky did a program that could solve sequences of the type that you're looking at in IQ tests in the 60s. So
Well, some
that's,
tests. I mean, you know, there are a lot of IQ tests.
The problem with an IQ test for machines, though, is that with people, they were developed originally with a criterion in mind. It was a commission in the Paris schools. Can you find a better way than close examination of every child to identify the learning disabled? And Benet won the commission by designing a test that did that. I don't know that we have a criterion to develop a test against by in that same way.
I think one of the problems if we go for we have to be very careful about how the way we set a metric, because sometimes if we set a problem, like solve this particular maze problem or something, there's a danger that we lose this general purpose, wide scope of intelligence, and people just focus on narrow engineering budgets to get the job done and claim the glory of getting a high score on the test.
I interpret what was being proposed actually is more that you should just compare systems to see which is better than another. It could be on a completely unconstrained task or environment, much like Hughes scaling. And at the end, you end up with a ranking. No matter how bad they are, you still have a ranking.
Does that one you can compare from year to year?
Does
that one you mean you can do horizontal comparisons against any one year? You can't do the sort of deep
yeah,
comparisons.
sure. I'm not saying as it stands, but I mean that sort of ranking.
You could also yesterday, when we got into this whole thing about a domain-specific test, it wasn't so much that we wanted to say it has to be domain-specific, as we will allow a domain-specific test. We're willing to say that something that plays chess very well and learns to play chess better is intelligent, even if it can't do a whole lot of other things. And that's going to be a lot easier to instrument.
Well, but that goes in.
severe problems with that personally.
It goes into contrast to what Mark is trying to say about
Right.
the generalization.
Right.
Mary?
So I think this is related to your point that I wasn't here yesterday either, so this is my tuppence worth. I'm sorry if I'm repeating something, but it seems to me that a lot of the discussion so far is very anthropocentric, and certainly there are many animals, non-human animals, that we would think of as intelligent, and so I would be interested in some kind of test that encompass those as well.
Yeah. Can I take Drew and then
Turing assumed that natural language ability was essential, which would rule out animals' basic. And I guess you can talk to dogs and octopuses.
Octopi.
Octopi. You could say octopus. So is that going to be a bottom line, that we have to have a natural language? I mean, it seems like.
I don't think so. I mean, you can have people who are mutes who are intelligent. I mean, symbol manipulation.
Oh no, I'm not saying that a creature is not intelligent if it can't talk. I'm just trying to somehow limit this test, and that would seem to be a limitation that we should keep, or it's at least worth discussing.
I think if I'm capturing what Drew is trying to say, is to have reasonable implementable boundaries where technology does not interfere with testing intelligence. So the fact that we might not have great natural language processing technology that can cover all the aspects of the language, that does not impact on our testing of intelligence. Is that correct? Or
Well, it has to be able to. All the agents under test have to be able to process natural language at some level. Now, of course, in year one, you're going to get agents that are not very good, but some are better than others. Which I like this idea that you're trying to find out who's better than who else. That seems. I always think that's a better way of going than trying.
can I let Rob? You wanted to say something?
Well, to add on, from the metric side, I think that the one thing that needs to be addressed is the complexity side, that there's different organisms with different complexities, and their intelligence is going to be taking into multiple factors. And right now the human may be the epitome for that, but even a bumblebee or ants or elements of biological systems that do show some traits of intelligence, to have a test that could be scalable amongst the different complexity of different intelligence factors and agents would be quite desirable. There's a lot of applications for that, and that could be for evaluating different systems to rank them according to different environments or different goals that they would need to do. And that's something that would be very fruitful for application needs.
It occurs to me that there's a number of places where computer scientists are trying to identify uniquely human abilities, and these are being used for. So Amazon has this service where you can get paid to answer questions. There's the reCAPTCHA test, and so it seems to me that the ongoing war between spammers and bots and so on and people has sort of siphoned out a few tasks that people presently are better at than machines that are quite specific and that aren't the Turing test. And so this might be something to take advantage of, to say, can we identify those places where folks are, ways that websites are protected, reCAPTCHA being the obvious one, and maybe make that something to see if we can target machines.
So your opinion is to see these little tests that seem to capture specific human abilities and try to build on it.
Right, so there's been, for the last 10 years, this large-scale, virtually automated process where these non-Turing test, uniquely human skills seem to be coming to the fore. Maybe take advantage of those.
But I think the capture thing for people involved in computer vision is actually a relatively trivial thing. I think that's more to put off your amateur sort of dodgy criminal who hasn't got access to sort of state-of-the-art vision systems. I don't think academically it'd be a particularly difficult task to reverse engineer a capture system.
So my understanding is that...
Just to kind of enforce what Mark is trying to say, even if it is challenging on vision side, that's where the problem between technology and testing intelligence comes. The fact that these bots don't have the technology to decipher these images has nothing, or in my opinion, doesn't say much about their intelligence. It is about their sensors and vision system rather than their intelligence.
Maybe we're just composites of lots of these little things that can do domain-specific tasks. So there's
two things, but I don't know reCAPTCHA, but capture. Number one, the T in capture stands for Turing, which is an example, by the way, of my paper where they don't know how many people are there because it's not a Turing test. And frankly, occasionally, although they seem to be getting better, some of the letters, the words you have to figure out or whatever is in the capture, we've got to read it. I wasn't able to. I mean, they were so smeared that I couldn't read what the damn thing was. I mean, now they've sort of lowered the threshold a little bit, but I didn't feel stupid. It was just too.
It's a vision problem.
One of the specific tasks we talked about a little bit yesterday that I think did not get into the notes is in games adversarial reasoning, figuring out what the other side is going to do. And that has a particular attraction that when you're playing a game and you're trying to figure out what the knights are going to do to your dragon, there's a computer program that directs the knights. There's a logic you can go back to and say, here is what the adversary is doing. How close did you get? And that's a test that one could apply to a cognitive robot and have a very good assessment of how well did it learn that.
I'm not sure how you can be so optimistic. I mean, suppose it developed a neural network or something like that was very hard to take apart and see what it learned or something, See what I'm saying?
I see what you're saying, but do I care how it did? All I want to know is how well it did.
Mark, did you want to make a comment and then I'll come to Darren?
Maybe I'm wrong, but my impression is that we have two different groups of people here. The larger group seems to take the human ability as the yardstick. So compare the machine to the human, and basically if they're indistinguishable, then the machine has succeeded. So that's intrinsically a deception task. And then there's other proposals coming. I don't know your name in the white shirt.
Rob Wilcox.
From Rob?
Yes.
And from Ed, basically talking about layered approaches, like different degrees of complexity, and starting way below human language. Personally, I find that more interesting as a way of forwarding cognitive systems in computer science, because it's closer to the real world.
As am I.
What are you?
We're on that team too.
But you were insisting on the natural language, right?
Yes.
So you think you can insist on the natural language and still go to that kind of lower level? I mean, doesn't that rule out the kind of animal cognition?
Yes.
Yeah, that's why I'm confused that you agree with me, because exactly natural language seems to be the thing that makes the human capabilities the sort of minimum requirement.
It's the agent would start off not understanding very well, but it would, the whole point is it would have to. The better it did, the better higher score it would get. Probably.
So are all non-human animals just choose?
I just don't want to. I don't think they're. What's interesting? I don't know. I'm thinking about practical applications. The agents are going to be interacting
Think
with
of a
people.
practical application, a rescue robot getting through a terrain. I mean, that's as practical as it gets, and it is commercially relevant. It has survival benefiting for some, I don't know, human in danger. But getting through that terrain requires some ability that not necessarily humans have.
But for all specific tasks like that, people already have testing regimes, evaluation regimes, where they test how well, if they're going to build such robots, it's wise to test how well it does. I don't see the point of us here sort of ordaining tests for very specific tasks, when those people will have to set up their own evaluation mechanisms anyway. I don't quite see why we... So, but there, are you really interested in assessing intelligence? You're just interested in assessing whether it can do a rescue task well, and that may or may not show something about intelligence. But is that really your goal?
Can I take Rob and then Murray and then Darren?
Well, I think that where that is providing ability is it's providing a perception of environment. Whether you use that for robotics for emergency, as in the DARPA Grand Challenge, to have a vehicle, go through a desert and an urban environment. It's kind of a moot point, the application, but it's still perception of the environment and the intelligence of that can be for many different applications.
Yeah, sure.
Then Murray?
So I want to kind of combine my earlier point about animals with something that Mark said earlier on, which is I think that one of the impressive things about animals and about animal cognition is that it isn't about an application or a domain. Animals can be very creative in solving problems, and I think that's what's very impressive. Animal cognition researchers have a whole battery of very interesting tests that they will confront an animal with, and some animals can pass these tests and some can't. And invariably, they're things that are quite different from situations they encounter in the wild, and it's their generic ability to adapt to those things, which I think is particularly impressive.
Are there any of these tests that use to test animals can be translated into a test machine intelligence?
Well, I mean, it would have to be in an embodied context, I guess, or at least a virtually embodied context, maybe in simulation. But they would be things that involve interacting with physical objects. And but yeah, of course.
I'll take Darren and then Mark.
So I was inspired a bit by this adversarial description of a task, and I'm aware of some research in cognitive psychology which gets people in something like a Turing Test scenario cooperating to try and solve tasks as a group, and often getting strategies that are thought to be, maybe something like in an NP-complete domain. And so I'm wondering about trying to see if we can create machines that become part of some group task and can get integrated well with others. So rather than adversarial, some kind of cooperative measure of intelligence. Can the machine sort of detect what's the goal here, how can I help the group proceed towards that goal, etc.
Would that, if we extend that to cooperative and collaborative and competitive, or collaborative and competitive behaviors, do you think that would be even more interesting? Because for a while I was interested in how, in even the animal kingdom, you have animals collaborate, and animals of the same species can compete on food, and how you can build relationships and break these relationships.
So you can put the two together, have tasks which require collaboration among groups, and then collaboration among a group, and then competitive behaviors across groups, something like that.
Yes. Interestingly enough, we had a PhD student who did his PhD on that. Based on the little tests he'd done, actually the results were the same, whether they are competing or collaborating. We didn't know what to make of that, but that's interesting. Mark?
Yeah, I'm trying to think of some sort of unifying way forward here. Part of me is drawn to John and Drew's sort of interest and emphasis on human language. It seems to be something uniquely human about us that we have this language, and people like Heidegger have argued that through language we can have access to common sense knowledge and bring a lot of cultural knowledge to problem-solving situations. So it just seems to me there are many good reasons why language ought to be integrated into a test. But also the kind of engineer, the latent engineer in me that always wants to kick free, is thinking, well, it'd actually be very useful to have a series of graduated tests. And the point I made earlier about having a test in an unconstrained environment sort of seems interesting as well. So I wonder whether there's scope for having some sort of robot test where we instruct the robot with as natural language as possible to do some task in the real world, and over the years we'll be able to hopefully engage in richer and richer verbally spoken interactions, or for that matter text interactions with the machine, and it will operate to solve some problem in the real world.
I actually have kind of a question mark about language, because if you step out of our human being and we listen to humans, so assume you don't know any language in this world, and you step out and listen to the human, all you hear are a sequence of sounds. I'm not very good at catching the separation of sounds. So whenever I listen to new language, the sounds, it might be a bird singing, a human talking, or a dolphin clapping their hands. So if you take it from that abstract level, our natural language, or language is a sequence of sounds. How that differ, except for the sophistication of it, from a language used by birds?
I think it differs in very significant ways. Not least, it allows us to build culturally and pass information from one generation to another that allows us as humans to build things like computers. I've yet to see what the chimpanzee build a computer, or a slug build a computer, or anything remotely similar. And I think part of our ability to do that is linguistically based.
Yeah, I was just going to say, I presented yesterday an approach based on human child development, and the idea that we might be able to use those tests, those sort of stepped tests, on our way to actually then finally using the final Turing test with all its linguistic complexity as the sort of final stage of that. And I think that to a certain extent is an agreement with Murray there, where obviously there are a set of established tests for animals and for children, and therefore can we make use of those and translate those in the first instance?
Yeah, absolutely.
Is it Doug, then Lesbian, and then you don't have, okay.
Okay, this is sort of off the deep end or a different branch, but I just want to go back to it in terms of getting 3 methods of grading this Turing test. If you want a graded test, one, you could have the length of the time, the 4 ways, let's say, the length of the time that the test is held. When it was held for 2.5 minutes, some of the computers were judged as humans. That was at 2008 in, where was it? Reading. You can have the test in which the human is a young person, a child. So now you're comparing the computer with a 7-year-old, an 8-year-old, 11-year-old. You can have the test where the judge is a child, where you have a 7 or 8 or a 9-year-old old enough to explain which is a machine and which is the human, and you can type that, maybe either type or have somebody ask you have the questions, or audio visual. And the other thing, of course, is that you can have a restricted, perhaps dictionary or lexicon, where there are only a certain, limited number of words that one could find in the dictionary of a 12-year-old or a 10-year-old and so forth. And then you would have, your unrestricted conversations, your Turing test, but you would have increasing complexity and difficulty. Now, I'm not necessarily recommending these, but I mentioned them as possibilities back in 1994 when I wrote my response to Schieber, that it's not that I'm against restricted conversations. It's just that it should not be restricted to certain domains, but certain limits in terms of, children, or in certain number of words or certain lengths of strings. You can't have a sentence with more than 7 words, like a super tweeter. What is it? Twitter? And that's just where I'm at. Anyway, but you could have, you can only use 7-word sentences.
You can have them exchanging haiku.
Well, whatever, exactly. It's just to point out, this is a very light thing, but if you're interested in, progression or regret, there are different ways of using a Turing test and increasing the complexity. In my opinion.
Okay, I just wondered whether it's worthwhile going back to the some of the cultural context of the original proposal, and particularly the word intelligence, the role played by word intelligence, and to what extent we're kind of taking over something uncritically, and also the way the word intelligence figures in the phrase artificial intelligence, which we all kind of signed up to when we came to this conference, but which also had its own cultural specificity in 1956, and which are tied up probably with with IQ, which has evolved since then. People have thought very critically about what IQ tests measure, and possibly also with intelligence in a sort of more military or surveillance kind of sense. In any case, Turing started his paper, Can Machines Think? And then he went on to talk about intelligence, and the word intelligence appears in the title of the 1950 paper. But there are lots of other things that we could be investigating for such a test, such as thinking, whatever that we want that to mean, cognition, which other people have mentioned. Someone mentioned creativity, maybe also wisdom, which I mentioned earlier. And maybe a whole load of other things, and maybe that's the variety of near synonyms to intelligence and possible other target properties ought to be looked at.
I may add to your list emotions, which I'm fascinated by, and how it impact our ability to memorize things, which effectively affect our decision making and thinking, if we may say.
And of course, emotional intelligence people have proposed as a kind of alternative or addition, and there are various other kind of multiple intelligences that Howard Gardner has proposed.
Sorry, I think Mark.
I'm sorry. Okay.
Mark,
go ahead. No, you go ahead. It's fine.
I was just trying to sort of build on Ed's idea. It seems to me that we can sort of try to bring a lot of ideas to focus on Ed's proposal. If we had these different stages, if we involved language along the way, as Hugh said, not necessarily restricting the language to a potty scenario or a house elf scenario, but just general, simple, childlike language that was scaled in proportion to the year of the test or the level of the test. And that, if these tests were then directed to along the lines that Ed suggested, where there's a body of cognitive psychology that's developed specific tasks, but we can integrate language into those tests, then that might be an interesting proposal.
Yeah, language is part of obviously some of it.
One dimension that I think we should be conscious of and ideally make a conscious decision about is the degree to which a given test encourages principled solution versus hacks. So coming from a language technology department where deep parsing is one of the core competences, with a deep parser you wouldn't have a chance to pass the Loebner test and win it. So basically no offense, but the Loebner test encourages pattern matching approaches. I don't know what the systems actually do, but that's my naive impression. And I don't think that this really drives the principles of computer science forward.
Can you tell us more about what you mean when you say a deep parser couldn't pass the Loebner Prize?
Well,
First of all,
just
it's not
not
the
robust
Loebner
enough.
Prize, it's the Turing
It's
Test.
technology that exists.
Okay.
Yeah.
I mean, I tried to make the Loebner Prize a Turing Test.
Deep parsing.
I mean, that's
very good.
I
Very
mean,
good,
it's
yeah.
not that it's some weird things. It was at one time some weird things, but I think I'm on the track where you have a paired comparison and they're
Oh,
interesting.
very good. Then let me say the same thing about the Turing test.
Okay.
The mere fact that the principled approaches that exist to language understanding are not robust enough to deal with arbitrary input. That means you need to always complement it with superficial technologies in order to do anything with arbitrary.
We actually have some language experts
Oh,
here.
no.
Sorry. John,
No, I mean, probably all got similar reaction. Okay, it should encourage people to develop more robust parsers, and indeed some people are trying to do that. I mean, and there is a chance that in fact it will encourage that. I mean, the fact that for the moment, until those people catch up, people develop clever pattern matching, it is unfortunate perhaps. Although one might also say that I think what we do is actually just stupid pattern matching. I think I'm a person who believes in deep discourse processing and pragmatics and semantics and all that. So I love that stuff, and I hate the idea you could get the same effect just by trivial pattern matching. But the thing is, I think we do actually do some trivial pattern matching for some tasks, and eventually, hopefully, the robust parsing people will catch up.
Drew and then Mark.
No, not me.
Well, let me just endorse the point about hacks. I mean, since I was one of the organizers of the international planning competition, which is held every 2 years or so, in conjunction with the ICAPS conference, it definitely has encouraged people to focus on speeding up their algorithms a lot, using the most optimizing compiler, and it's been very discouraging because the attempts to push things forward haven't done too well. People tend to run the same dumb algorithm and hope for the best. As the problems get more complicated, it's really frustrating. And so it seems to me if you're interested in intelligence, you're interested in breadth. And so the way to get around this tendency to hackery is to first insist on natural language, because Turing did, why not? And second, natural language gives you the ability to redefine the problem or to define new problems on the fly. Okay? So I like the idea of having a virtual world, a fairly complex virtual world, but a well-defined world that doesn't change too much from year to year, so that you have to worry about embodiment, but you don't have to build a robot, which does seem a little bit beside the point. You could still do search and rescue and whatnot. You don't, and I think the judge is one of the weak points in the Turing test. So I want to have the task be well defined. That is, there has to be a winner. So somehow there's even though you're setting at different problems, there's a well-defined notion of who solves it faster, and therefore, takes that problem out of the arena, as it were. And finally, I would rank the judges on their ability to find problems that separate the winner from the next best competitor. So they get paid an amount that depends on that. So this requires them to have a good estimate in advance of the talent of the system. So they pitch their problems low enough that somebody could do well. But then they're allowed to use natural language at any level they think can be understood this year, and that enables them to generalize the problems as they go. So you have to rescue this, you have to rescue the baby that's over there on the other side of this rubble pile, but you can't bring the baby around this side because there's poison gas there or something like that. So you're allowed to introduce strange things that require some knowledge of natural language vocabulary as you go. So.
Just a few things. Okay, I cannot tell you how many criticisms I've gotten about the Loebner Prize in that it's only pattern matching. And I keep saying, and I've almost got it now, cut and paste, but it's not, that fact that they're doing it now doesn't mean that it has to be done that way.
True.
I mean, you have no idea. Well, take it from me, there are a lot of them. And there was something else I was going to say, but I seem to have forgotten it. So, but that's the main thing. There is not a rule of the Loebner Prize that it has to be pattern matching. I mean, at first, I'm waiting desperately for somebody to come up with something new. Oh yes, I remember what it is. In the very first contest, though, Richard Wallace, who came up with the entire Richard Wallace developed Alice, artificial intelligence language. I don't know if you're familiar with it. He won the Loebner Prize 3 times, and it was a simple language for pattern matching. And it worked. It won.
We'll probably take Mark, Sean, Rob, and break.
Okay, it's interesting that I mean, I have some sympathy with the notion that we should be looking at investigating language processing using well-formed and well-defined methods. But I think it's kind of interesting now with the rise of engines such as Google Translate that are based on statistical machine translation, just what you can do now with huge computing power and vast data sets. And yeah, I mean, I don't. Do we necessarily need? Would it for any possible competition that we defined? Would it be the case that we would insist on proper methods to solving the task, or would statistical methods be just as good as any other?
And add to exactly this point where we talked about yesterday of having the internet. So you have the knowledge, and as long as you have intelligent knowledge representation, enable the use of that knowledge and the techniques, whether it's statistical, then you could have, theoretically at least, unlimited knowledge. And then becomes the question, can you use all of that or not? Or am I taking your point too far?
Well, there's a famous point from Dennett in Cognitive Wheels paper where he talks about an encyclopedia with unlimited knowledge would still walk off the end of a cliff if it didn't have a means of accessing that knowledge in a reasonable length of time.
John?
Yeah, I think I respect your worries about the superficial. Is it Mark? Yeah. That's reasonable. I would, on other grounds as well, ask for a longer test. I think 5 minutes is becoming passé, perhaps. Even though systems are failing, we ought to go to a longer time.
Standard Loebner Prize, for what it's worth. I've said that if they can pass it for 25 minutes, they get $25,000.
Right. Yes.
And we get and they get the silver medal, and we go on to the audio-visual input.
Yeah,
I mean, it's not enough, but
Okay. Well, I'm sorry, I wasn't meant to be commenting about you. But yeah, I think it ought to have longer tests because I was a judge 1 year, and in 5 minutes I found it was very difficult to ramp up a sort of sensible context and really make a judgment. But also, although I'm not particularly in favour of the statistical approaches, because I think they miss out a lot in terms of meaning and pragmatics and so forth, I think you could get round the abilities of current statistical processing. I mean, if you're using the language to set problems of some sort or to probe the entity's understanding of some quite subtle issue, and I doubt very much that somebody could answer questions about something like that using purely statistical means at present, or even going out on the internet and using whatever Google tools might be available. But the last comment is also that statistical approaches have a lot in common in some cases and respects with connectionist approaches to brain modeling. So it's very easy to say, oh, it's just statistics. But actually, if it's clever enough statistics, it might actually, in some way, be actually quite close to the way the brain is doing some things. So I think there's a danger in dismissing purely statistical things out of court and saying, well, therefore it's not intelligent or something. Or something that could go out on the internet and get the relevant stuff efficiently and stuff. That would be amazing. I mean, to actually get really relevant stuff quickly and give it back and look as though you're engaging in intelligent conversation, I think that would be a pretty intelligent system.
I think the language is important, but I wouldn't think that that's the only vehicle of communication or in communicating a goal. That there's many intelligent agents that achieve goals, and it's not through language that element's communicated. Playing chess, it's not a verbal game, but There's definitely intelligence and Deep Blue's capability there, in just even in a hunter, victim models and games, the intelligence associated with that. The other thing to look at is collective intelligence of societies. Somebody mentioned that earlier, and it's a whole different realm maybe of measuring intelligence in that environment. And if we create a truly scalable means of measuring intelligence, it would be ideal if it could be applied to that as well.
Okay. On that note, probably we have to break for coffee, and just if I may give a quick summary of what I think key points, or should we leave it? Yes.
You guys summarize the key points, we'll argue about that for 15 minutes.
If you think this represents your ideas at any point, come and talk to me during the coffee break, and I'll amend the right?
So you can read your points.
You were in 2008, which I